Hello, today's concept is about the discontinuous reception. As the image says, your phone and the 5G tower a sleepy relationship, which talks in layman language that phone and the 5G tower they are not connected all the time. Means the phone is disconnected at the required time, and that is very important to save the power or energy of the user equipment or the phone. So this image describes the three modes, that is RRC connected and RRC inactive or RRC idle. So with the image detection itself, we can tell that RRC connected means that phone is active, RRC inactive phone is partially active, or RRC idle means the phone is sleeping. So this is a very important concept. So first I'm going to talk about the RRC connected. So here RRC connected, this image depicts the base station that is there, and this is the user equipment phone. So at the RRC connected state, the both UE and base station they are connected. Means the RAS process is happening. Means the data radio bearers and the signaling radio bearers are both are connected. Means both are active when it comes to RRC connected state. And here at the bottom, the graph also tells that the RRC is connected. And the another concept is RRC idle, where the base station and the UE, they base station and UE, it is not connected. Means both the data radio bearers and signaling radio bearers both are released. So this depicts the RRC idle state. Means the phone and the base station they are not connected itself. Both are released. So here the concept lies like this. Means from RRC idle state to come to come back to RRC connected state, it has to go through certain process using the core network. So this will cause latency. There will be, so from RRC idle state to RRC connected state, UE, from RRC idle to RRC connected state, it has to go through certain processes in the core network, which is not feasible. There is a lot of latency in this process. So in order to avoid this process, there is another mode called as RRC inactive state. So in the RRC inactive state, UE and base station, data radio bearers are released, signaling radio bearers it is connected. Means it is partially connected. UE and base station they are partially connected. How this mode is going to help in reducing the latency? Means here in RRC inactive, data radio bearers is released and signaling radio bearers it is connected. So from RRC inactive state to RRC, in RRC inactive state to coming back to RRC connected mode, faster radio access network happens. Means only data radio bearers has to be connected. So this is a lesser latency process as compared to UV coming back from RRC idle to RRC connected state. So RRC inactive avoids this core network and latency will be reduced. So this will give a faster radio access network. Coming to the one step higher concept, means we have a question now: how UV is in RRC inactive or RRC idle state? Means when UV, when that is in RRC inactive or in RRC idle state, it has it has to be ready to uh, means whenever the base station wants to transmit the downlink data, UE has to be ready to take that data. So that is one main big main big question, that question mark that lies in this concept. did this carefully. When UV is in RRC inactive or RRC idle, how the base station transmits the downlink data? That is one big question mark. So at that time, um, so assume that here in the bottom graph, this is RRC connected, and it is, and at this time UV can transmit, base station can transmit the downlink data to UV directly, as it is already RRC is connected. Data radio bearers are active, signaling radio bearers are active. It can transmit the data very easily at the RRC connected state. But in order to transmit, in order for base station, in order to transmit the downlink data to the UE at the time of RRC inactive or at the time of RRC idle, is a big question mark. So at that time, a special concept called a paging signal comes into picture, where uh, the base station, it sends the paging signal. It sends the paging signal to UV. At that time, it has to become active. Uh, active UV should become active to receive the downlink data. But in order to receive the paging signal, UV has to be RRC connected itself. So at the time of RRC inactive, if the paging signal is received, that becomes null. Means if the paging signal is received by UV at the RRC inactive or RRC idle, it goes in vain. So for that, even in RRC inactive or RRC idle, we should have a concept of RRC connected, so that if at all a base station has to send the downlink data to UV, it has to be in the state of receiving that downlink data. So in order to activate that, paging signal is sent first. The paging signal is sent by the base station. So for that, UV has to be in the RRC connected state even at the time of RRC inactive or RRC idle state. So here, this is a big question mark. So here comes the concept, where in even in RRC inactive or RRC idle, there are active and inactive states introduced. This is a higher level concept, where in RRC inactive also and RRC idle, means UV is not connected to base station, but still UV has to wake up and sleep at the periodic, in the periodic state. It has to wake up and sleep in a periodic state, so that if at all base station has to send the downlink data, it should be in the state of, if it should be in the state of receiving the paging signal. So this concept is DRX active and DRX inactive state, means discontinuous reception. In the word itself, discontinuous reception means uh, there should be discontinuity in the sleepy mode. So discontinuous reception should happen. So at the active state, if the paging signal is received from the base station, it should be in the state of receiving that downlink data sent from base station. So that is the main concept here. So here, DRX active and DRX inactive state, means UV in the state of receiving that paging signal from the base station, even when the UV is at RRC inactive or RRC idle state. This is a very important concept, DRX active and DRX inactive state. This is how the energy of your mobile or your user equipment, or whatever is your mobile set, this is how the power of the your mobile is saved by this DRX active or DRX inactive state. But if we think in a broader but we in if we think in a broader perspective, uh, when UV is in RRC inactive or RRC idle, how base station transmit the downlink data.